Hello guys, welcome to Magic Math Stat.
Today we are learning about factorial operator. Like addition, subtraction, multiplication, division, factorial is also a simple operator. It was created for using in combinatorics like counting arrangements of objects, and in today's video we are going to discuss about the natural factorials, that is factorials of positive integers. Let's define factorial. If n is a positive integer, then n factorial is the product of all positive integers or natural numbers up to n. That is, n factorial equals to 1 times, 2 times, 3 times, and the product goes on up to n minus 2 times, n minus 1 times n. If we write it in the reverse order, we get n factorial equals to n times n minus 1 times n minus 2 times, and it goes on up to 3 times 2 times 1. Well, we are going to use the second expression for our ease of calculations. So factorial is pretty simple. Though we have one assumption in this chapter, that is 0 factorial equals to 1. Wanna know the logic behind this assumption? Then comment below. I will surely make another video about it. Now let's look at some examples. 2 factorial equals to 2 multiplied by 1, that is 2. 3 factorial equals to 3 times 2 times 1, that is 6. 5 factorial is 5 times 4 times 3 times 2 times 1, that is 120. And 10 factorial is the product of natural numbers up to 10, that equals to 3628800. Obviously, you can understand that big ones like 10 factorial, you have to use a calculator because the calculation by hand is not practical. Now let's discuss about the properties of factorials. We know that n factorial is the product of first n natural numbers. So we can write n minus 1 factorial equals to the product of first n minus 1 natural numbers. Now look at the blue rectangle in the first expression. That is exactly the product of first n minus 1 natural numbers. That is n minus 1 factorial, right? And hence we get n factorial equals to n times n minus 1 factorial. Let's look at some examples. 5 factorial equals to 5 times 4 factorial. 8 factorial can be written as 8 times 7 factorial. 20 factorial can be written as 20 times 19 factorial. And 10 factorial can be written as 10 times 9 factorial. Now in the last case, we are gonna break it more. Let's see how. We can break the 9 factorial in 9 times 8 factorial. And if we break 8 factorial again, we get 8 times 7 factorial. So the 10 factorial is 10 times 9 times 8 times 7 factorial. Hence we can understand that the bigger factorials can be written in terms of smaller factorials by just leaving the bigger integers as products. Like in this case of 10 factorial, if we take out the bigger integers than 7, that is 10, 9 and 8, then the expression becomes 10 times 9 times 8 times, at the end we get 7 factorial. Let's see some more examples with different operations using factorial. Simplify 10 factorial divided by 7 factorial. Well, first we break the 10 factorial as previous. So we have 10 times 9 times 8 times 7 factorial divided by 7 factorial. Then the 7 factorials cancel each other out and we are left with 10 times 9 times 8. That's nothing but 720. Next one is a bit more complicated. 20 factorial divided by 15 factorial times 6 factorial. Now the biggest one here is 20 factorial, and in the denominator the biggest one is 15 factorial. So we are gonna divide 20 factorial by 15 factorial first because 15 is closer to 20 than 6. So we break the 20 factorial as previous and we get 20 times 19 times 18 times 17 times 16 times 15 factorial divided by 15 factorial times 6 factorial. Now the 15 factorials cancel each other out. So now we don't have any factorials on the numerator. So we can't cancel 6 factorial like previous one, and hence we break 6 factorial and simplify. At last we get 19 times 17 times 8. That gives us 2584. Now next we will see something interesting. N factorial divided by n minus r factorial. Now n minus r is obviously less than n. So let's start breaking n factorial. We know n factorial can be written as n times n minus 1 factorial. Now n minus 1 factorial can be written as n minus 1 times n minus 2 factorial. Then we can break n minus 2 factorial. And if we break r times, we get n times n minus 1 times n minus 2 times n minus 3 up to n minus r plus 1, and at the end n minus r factorial. Now if you ask why I have written n minus r plus 1 before n minus r factorial, that's because n minus r plus 1 is 1 greater than n minus r, that is the bigger integer next to n minus r. Now n minus r factorials cancel each other out, and hence we get n factorial by n minus r factorial equals to n times n minus 1 times n minus 2 times n minus 3 times up to n minus r plus 1. We will use this expression in combinatorics a lot. So that was all for factorials.
So if you have enjoyed the video, then one like is appreciated, and also share the video if you know someone who needs this lesson. Guys, I am thinking about starting online classes, and my Facebook page link is given in the description, also in the video. I think you can see that. So if you want to contact me, then you can do that using the Facebook Messenger button in my Facebook page. So thanks for watching, guys. I will meet you in the next video.